Alright guys, back for another stab at it. Okay, got a couple problems to get through today. Let's start with this guy. And the first thing I see is we have a GCF of 2. So I'm going to pull that guy out. Okay. Secant squared of x minus 2 secant of x plus 1 equals 0. And that is a perfect square trinomial. Okay, so let's see. Secant of x, that would be minus 1 squared equals 0. And let's check that. This guy squared is secant squared. 2 times secant times 1. There we go. 1 squared. Yep, perfect square trinomial. Okay, so let's see. If this is equal to 0, then that means secant of x minus 1 equals 0. So that would mean that the secant of x has to be equal to 1. And since we're working on the unit circle, I will change that into its reciprocal. So if I take the reciprocal of both sides, okay, that would be cosine of x equals 1. Okay. All right, so let's see. When does this happen? Okay, so let's go here. When is a cosine equal to 1? Well, cosine is our x coordinate, and the only time the cosine is equal to 1 is right here at 0 radians. Okay, so that only happens at 0 radians. Okay, so let's see. On 0 to 2 pi, we have one solution. X equals 0. Okay, and so let's see. On the set of real numbers, that would be x equals 0 plus 2n pi, where n is an integer. And of course, we could drop the 0, and so the best way to put this would just be x equals 2n pi. So it'd be all the even multiples of pi, where n is an integer. That would be the best way to put it right here. Okay, so that guy was really quick and really easy. Okay. All right, let's see what we got going on here. Okay, this guy's a little different. Let's see, because I've got cosine and sine. Okay, there's no way to change this cosine to sine. I could do it if that was cosine squared of x. I could do it using a Pythagorean identity. Okay, but I can change sine squared of x into cosine. Okay, so we say, okay, we go to our Pythagorean identity. Sine squared x plus cosine squared x equals 1. And I need to make a substitution there so that I get everything in terms of one trigonometric function. Okay, so if I move this cosine squared over, I get sine squared x equals 1 minus cosine squared x. Okay, and so I'll make that substitution and see if this helps me out. All right, so I got 1 minus cosine of x equals, don't forget the 2 out front, times the quantity of 1 minus cosine squared of x. Okay? All right, so let's use the distributive property. Get rid of these grouping symbols, so that'd be 2 minus 2 cosine squared of x. Okay, so let's think about putting it in standard form. So I'm going to move this guy over so it becomes positive. I'll move this guy over so it becomes negative. So let's see, that would be a positive 2 cosine squared of x. Okay, I have this minus cosine of x already over there, like that. And then I'd have 1 minus 2, so that'd be minus 1 equals 0. And it looks like some of the problems we've done, so let's see if we can factor this guy. Okay, so let's see, split that guy up. Okay, so that's gonna have to be 2 cosine of x and cosine of x. And obviously the 1 would just be 1 and 1, so let's see. One's got to be plus, one's got to be minus, so I'm going to have to put the minus here and the plus here. so that our O's and I's will give us that. Okay, now we're good. All right, so let's see. I would get 2 cosine x plus 1 equals 0, or I would get cosine of x minus 1 equals 0. So let's see, it's subtract 1, divide by 2, so this would mean cosine of x has to be a negative 1/2, and this would mean that cosine of x equals 1. All right, let's see, so we go to our unit circle. Let's go to our unit circle, and let's see, when does that happen? Okay, on 0 to 2 pi. Okay, x equals. Okay, so cosine of x is negative 1/2. So when is our x coordinate negative 1/2? Looks to me like that would happen at 2 pi over 3 and 4 pi over 3. Okay, our x coordinate is negative 1/2. So 2 pi over 3 and 4 pi over 3. Okay. 2 pi over 3 and 4 pi over 3. And then when is the cosine equal to 1? So when is our x coordinate equal to 1? Well, that only happens here at 0 radians. Okay. 0. So we got 3 solutions on 0 to 2 pi. So if we go the set of real numbers, okay, that will give us x equals 2 pi over 3 plus 2n pi. That will give us x equals 4 pi over 3 plus 2n pi. And that would give us x equals 0 plus 2n pi, so I'll just put 2n pi, where obviously n is an integer. Okay, that one wasn't too bad. There we go. Let that guy out of the way. Let's see what this guy looks like. Very similar to the last one, except here we have the cosine is squared and the sine isn't. So why don't we attack it the same way? So let's see, we go sine squared of x plus cosine squared x equals 1, and I need something to substitute in for cosine squared. So let's see, cosine squared of x would be 1 minus sine squared x. So that guy goes right in here, and we'll see what happens. Okay, so we have 2 times 1 minus sine squared x equals negative 3 sine of x. Okay, so that will give us 2 minus 2 sine squared x equals negative 3 sine of x. And let's bring this stuff over to the right so that this term becomes positive. So I'll bring this guy over as well. So let's see, well, with 0 equals 2 sine squared x, I have a minus 3 sine of x, and then I bring the 2 over, it becomes negative. Okay, GCF is 1, so that doesn't help. So let's see if we can factor this guy. Okay, so I'd have a 2 sine of x and a sine of x. This guy I can only split it up 2 and 1. So it looks to me like the 2 has to go here and the 1 has to go there, and this has to be negative and that has to be positive. Right, and so the O's and the I's will give me this. Okay. All right, so we get 2 sine of x plus 1 equals 0, and we get sine of x minus 2 equals 0. Okay, so if I subtract 1 and divide by 2, I get sine of x equals negative 1/2. And here I add 2 to both sides. Sine of x equals 2, and this gives you no solution. Okay? All right, because remember, okay, our range of sine and cosine goes from negative 1 to positive 1. Okay, and this guy is not in there. Okay, so that gives us no solution. Okay, so let's see. If we go to 0 to 2 pi, Okay, so when is the sine negative 1/2? We go here. Remember, sine is our y-coordinate, so when is the y-coordinate negative 1/2? So it looks to me like that happens at 7 pi over 6 and 11 pi over 6. Okay, so we have two solutions, 7 pi over 6 and 11 pi over 6. Okay. All right, so we're gonna take a look at it on a set of real numbers. So x equals 7 pi over 6 plus 2n pi, and x equals 11 pi over 6 plus 2n pi, where once again n is an integer. Okay, third one down. It's not bad. Okay, let's see this guy. All right, so we got tangent squared and secant squared. So it seems to me I'm probably going to have to make a substitution here using a Pythagorean identity. And so we know that tangent squared of x plus 1 equals secant squared of x. Okay. So it looks like we could make a substitution for tangent. Okay, I could say, well, tangent of x is equal to secant squared minus 1, and so everything would be in terms of secant squared. Or I could make a substitution for secant squared, just putting in tangent squared x plus 1, so everything is tangent squared. And it's not going to make any difference one way or the other, would be my guess. So I'm going to take this guy and put it right in here. Okay, because I'd rather work with tangent than secant for whatever reason. Okay, so let's see what happens. Okay, when I do that. So we get 3 tangent squared of theta equals 2 times the quantity of tangent squared theta plus 1 plus this 1 on the outside. Okay, so we got 3 tangent squared theta equals 2 tangent squared theta plus 2 plus the 1. Okay, so let's see, if I subtract 2 tangent squared from both sides, that'll just give me tangent squared theta equals over here 3. Okay, so that means the tangent of theta has to be either the positive or negative square root of 3. Okay, so then we go to our unit circle. Okay, so we know it has to have something to do with either pi over 6 or pi over 3. That's the only way to get sine over cosine and get that radical 3 in there. And I'm pretty sure it's going to work here at pi over 3. Because if we take a look at tangent, okay, of pi over 3, okay, that is going to be our y-coordinate sine over our x-coordinate cosine. Okay, so that would be radical 3 over 2 divided by 1/2. Radical 3 over 2 divided by 1/2, which is the same as radical 3 over 2 times the reciprocal of 1/2, and those guys cancel and give us radical 3. So I'm going to need a 1/2 as my x-coordinate and a radical 3 over 2 as my y-coordinate. Okay, so let's see. Tangent of theta is equal to positive radical 3, and then I have to consider tangent of theta equals negative radical 3. Okay, so let's just deal with positive radical 3. We know that happens at pi over 3. We know that. Okay, so we know theta here has to be pi over 3. Will it happen anywhere else? Well, wouldn't it happen down here at 4 pi over 3 as well? Because you'd get a negative divided by a negative, which is a positive. So that's going to happen at 4 pi over 3 as well. Okay, then right here, well, we need to have the 1/2 and the radical 3 over 2, but we need to have one of them negative and one of them positive. So that happens at 2 pi over 3, and it also happens at 5 pi over 3. Okay, so 2 pi over 3 and 5 pi over 3. Okay, so I got all my solutions. So let's see. On 0 to 2 pi, okay, theta, and if you put x equals rather than theta, it doesn't make any difference. We'd have pi over 3, we'd have 4 pi over 3, we'd have 2 pi over 3, and we'd have 5 pi over 3. Okay, and then once again on the set of real numbers, theta equals, theta equals, theta equals, theta equals. I know I sound like a broken record. Pi over 3 plus 2n pi, 4 pi over 3 plus 2n pi, 2 pi over 3 plus 2n pi, and 5 pi over 3 plus 2n pi, where once again, n has to be an integer. Okay, well, that will wrap it up for today. You guys stay safe, and miss all of you.